Hi. What we're going to do in this video is basically work through a force problem. Okay, so we've got this problem here on the page. Two people are pushing on a 90 kilogram wheeled cart. This is being shown from above, so the two circles there, we're looking at the tops of the two people's heads, all right, as they push the cart across the page from left to right. If the wheels roll and swivel without friction, then what are the magnitude and direction of the cart's acceleration? So, first thing we're going to do, since this is a force problem, the first thing we're going to do is we're going to draw a force diagram. A force diagram, then, I'm going to make a dot, which represents our object, and then I'm going to draw arrows, which represent our forces. Okay. Now, I'm drawing this from the top, which means that we aren't going to be able to include things like normal force and gravity from this perspective. But that's okay because we're only interested in the horizontal motion here, and those two forces aren't really going to have any effect on it since there's no friction. Okay. So, let's see. Let's start with this person. I'll call this person 1 and this person 2. And person 1 is exerting a force on the cart this way, okay, at an angle of 40 degrees, all right. You'll have to bear with me a little bit because I'm not really that good at using this pad. Let's see, force 2, the force from person 2 is that way, and it's at an angle of 30 degrees, okay. So that's really all the forces that we've got, from this perspective. And so now we're going to take our force diagram here and we're going to use it to apply Newton's second law. So first we're going to say the sum of the x components of the forces is equal to the mass times a sub x. Okay, let's see, this is force 1, this is force 2, and so we're going to say F1x plus F2x equals m times a sub x. All right. F1x is going to be, let's see, F1 is 80 newtons times the cosine of 40 degrees. Okay. Actually, strictly speaking, I should say minus 40 degrees, but since we're doing cosine, it really doesn't matter. Okay, when you have negative angles, that you got to worry about that when you take the sine. Let's see, plus 110 newtons times the cosine of 30 degrees. So that's the x component of this person's force. All right, and that equals the mass, which is 90 kilograms, times the x component of the acceleration. And when we work this out, we find a sub x is about 1.74, and the units there are meters per second squared. And then we do the same thing for the y components. So the sum of the y components of the forces is equal to the mass times a sub y. That gives me, so this is going to be F1y plus F2y is equal to m a sub y. So we've got, let's see, F1 once again is 80 newtons. We want the y component, so this is going to be the sine of the angle, which is minus 40 degrees. Okay, that minus sign, when we do that, that's going to give us a minus sign overall, which is right because that force is down in our drawing. Plus, the other force is 110 newtons, sine of 30 degrees, and that once again is 90 kilograms times a sub y. And it turns out these two forces are going to almost completely cancel each other out. So when we plug all this in and we calculate a sub y, we get a sub y equals 0.04 meters per second squared. All right. So we've got the x and y components of our acceleration. And let's see, the problem says we want the magnitude and direction of the cart's acceleration. So to get the magnitude of a vector from its components, remember we say that a is equal to the square root of a sub x squared plus a sub y squared. This is going to be the square root of 1.74 squared plus 0.04 squared. And this actually gives me 1.74 again, meters per second squared of the units. Basically, the y component is so small that the x component is pretty much the whole thing. Okay, so this is the magnitude of our accelerations. So that's part of our answer. Let's see. Then we want the direction as well, and to get the direction, we say that theta is equal to the arctangent of ay over ax, which is the arctangent of 0.04 divided by 1.74. And that ends up giving us, when we punch it in, theta equals 1.3 degrees. Okay, so in other words, that's a very small angle. So in other words, the cart is being pushed almost straight from left to right. Okay, so that's the direction. And we're done.